morning, brothers.
Good morning, sir.
Good morning.
So, today, inshallah, we have to finish chapter number 10 because only the problem is left. Am I right? The numerical question is left. Theory we already finished. Am I right? Am I right or not?
Yes, doctor.
Okay. So, brother, before I start the lecture, I would like to remind you regarding our quiz 2. I already gave the announcement in the blackboard. Understand?
And we say
I already gave the announcement in the blackboard. Please prepare well for your quiz 2. Quiz 2 portion is only 2 chapters, chapter number 8 and 9. And you are going to write your exam during your class time. So I prefer to conduct the exam next week, Wednesday, same time. Okay, from 9:10 to 9:50. So you just come to the class and then give the attendance and then go for writing your exam. Understand? Inshallah, next week.
Yes, sir.
Okay, brother. Better I can share my slides. Okay. So these are all the 5 problems today we are going to discuss in chapter number 10. Problem number 4, 16, 23, 32, and 45. Please read the question carefully and try to answer based on the information given in the question. The angular position of a point on the rotating wheel is given by theta, which is equal to 2 plus 4t square plus 2t cube, but theta is in radian and t is in second. That means here the rotating wheel, its angular position is given in terms of equation with respect to t. So therefore, my theta, which is equal to 2 plus 4t square plus 2t cube. But theta is in radian and t is in second. At a time t is equal to 0, what is its angular position? Because this is your position, but what they just need the first question, at a time t is equal to 0, what should be your theta value? So what you have to do, take this
Instantaneous.
Take this t is equal to 0 and then substitute, because this is your position equation. Am I right? This is your angular position. Again, they need the angular position when time t is equal to 0. So what you have to do, take this t is equal to 0 and substitute here. So what you will get, theta, which is equal to 2 plus 4 multiplied by t square, which is nothing but 0 square, plus 2 multiplied by t cube, which is nothing but t, which is equal to 0, 0 cube. Am I right?
Yes, you are right.
So now what should be the answer? The answer, theta, which is equal to 2 radian. Clear?
There.
Now second question. Again, at t is equal, yes,
Oh, it's easy.
clear. Okay, second question. At t is equal to 0, what is your angular velocity? That means again you are going to take the same time, but what they need the angular velocity. Okay, so if you want to find the angular velocity, we know the formula omega, which is equal to d theta over dt. Am I right?
Yes.
So how I can write d over d theta of theta value. Theta, I'm going to take this value, I'm going to substitute here. So if you substitute here, what you'll get, which is nothing but 2 plus 4t square plus 2t cube. So when you just differentiate with respect to time, so what you will get, this constant, the differentiation of the constant 0. So first term will gone, second term 8t, third term 6t square. Am I right?
Yes, you are right.
Now we are going to find omega value. That means angular velocity at a time t is equal to 0. So at a time t is equal to 0, what is my omega? My omega, which is equal to, I have to substitute t is equal to 0 in this equation. So what I will get? 8 multiplied by 0 plus 6 multiplied by 0 square, which gives you
0.
0. That's it. Clear?
No.
دكتور
Yes.
The line اللي هو 8 c plus 6 t square. I don't understand.
Brother, if you not understand means you are not listening the class from chapter number 2. Don't you know how to differentiate the equation with respect to t? Huh? How we got this equation? You are just asking the very basic question. We already finished this chapter in chapter number 2.
Oh, I remember now.
X
But,
power
But,
n into x
no.
power n minus 1. This rule you have to apply here. So
Yes,
that
yes,
means this becomes 80, this becomes 60 square. Understand?
That's no understand.
Okay, let's we go for third question. What is your third question? At time t is equal to 3 seconds, what is your angular velocity? Brother, angular velocity just before we find, this is our angular velocity. Therefore, I can just directly write my angular velocity 8t plus 6t square. Now I have to do only one thing. What I have to do? I have to take this 3 and I have to substitute here. So if you substitute, what you will get? Omega, which is equal to 8 multiplied by 3 plus 6 multiplied by 3 square, which is equal to 78 radian per second. Understand? Understand?
دكتور
Yes, yes.
angular
Okay.
velocity it mean like omega.
Yes,
Yeah. Oh,
it's
sorry.
omega. Okay. Let's become for fourth question. What is your fourth question? Angular acceleration. So at a time t is equal to 4 seconds, what is your angular acceleration? What is our angular acceleration? We already studied this formula, which is nothing but d omega over dt. So once you find this d omega over dt, after that, what value you have to substitute? You have to substitute 4 seconds. So what I'm going to do, I'm going to take this omega and I'm going to substitute here. So if you substitute, what you will get? D over dt of my omega value is 8t plus 6t square. So if I just differentiate these, what I will get? I got 8, and if I just differentiate with respect to time, I got 12t. Am I right? Now what I am going to do? I'm going to take this 4 second. I'm going to substitute here. If you substitute, what you will get? My alpha, which is nothing but angular acceleration, it is equal to 8 multiplied by 4 plus 12 sorry, there's no t, am I right? So 8 plus 12 multiplied by 4, which is equal to 56 radian per second square. Understand?
Understand.
Okay. What is the answer for the last question? What they ask in the last question? Could you please read the question?
Is it angular acceleration constant?
Is
A.
its angular acceleration is constant or not? They are just asking whether your acceleration value is constant or not. What is your answer?
8,
No.
teacher, right?
Is it yes
I
or
think
no? Huh?
Yes, doctor.
Oh, it is yes. Is it a constant?
No,
You get the
no.
constant. Brother, listen, first of all, understand the question. If you put time t is equal to 4 seconds, you got 56. Am I right? If you substitute time t is equal to 5 seconds, do you got the same 56?
No.
So that means your acceleration is not a constant. It always depend on the
Fine.
time. So it is not a constant. So not a constant. Clear?
Doctor, this is a question. It's like what we solve in midterm, right? You know, it's common
Yeah,
in
that's
chapter 2, I think. With
That's what I
derivative.
said. That's what I said. You already studied in chapter number 2.
Yeah. I think
Okay.
we have solved same this question. Find the
Yes.
instantaneous velocity and find the instantaneous acceleration.
Yes, correct.
Thank you, doctor.
Okay, welcome. Okay. Let's read the second question.
Teacher,
May we
could you go back, please? I want to ask you something. when he said in the A and B, if he said angular position, I just apply zero
Because
without
in the
differentiation.
question they already give the position equation. In the first question, they just need what is your angular position when t is equal to 0. So what I did, I just simply take the 0 and substitute here.
Okay, but if he said it's angular velocity, I will.
You have to
take the
differentiate one time
derivative.
and then you have to substitute the value.
Why angular velocity derivative, teacher? I remember that if he said
What is this formula? What is this formula? You should not ask this question, brother. Brother, you already finished midterm exam. What is this formula?
I know how can I derivative, but why here in question? I mean,
Why here means in the question they are asking find the angular velocity and then substitute t is equal to 0. Why this question means question they are asking like that. You have to find the angular velocity. So angular velocity means if you differentiate the position with respect to time, you will get the angular velocity.
and angular acceleration as it is.
If you differentiate the velocity one more time, you will get angular acceleration.
Okay, thank you.
Clear, step by step. You have to just write and step by step.
Doctor,
Yes.
please go back. D, yes. Number D, doctor.
This one?
You wrote 8 plus 12t. You delete t with 8. Why?
If you differentiate this t one time, what will get? You'll get only 8. Am I right?
Okay. Now another time derivative.
Yes.
Okay, thank you, doctor.
Let's we go for second question. What is given in the second question? A merry-go-round rotates. Merry-go-round means if you just go to the entertainment park, there is some rotating wheel. The children they are playing. Am I right? So if you just go to the merry-go-round, it is rotating from rest with an angular acceleration 1.2 radian per second square. That means the alpha value is given, which is nothing but 1.2 radian per second square. How long does it takes to rotate through first two revolution and the second question the next two revolution? So how long means they just need the time. So how long it will be take for completing two revolution? So listen carefully. We don't know the time. So for completing this two revolution, we don't know the time. That means this revolution is referred as theta minus theta naught. Am I right? So theta minus theta naught is nothing but here they mentioned two revolution. Initial position and final position. When this final position came, how much rotation it did? 2 revolution. For this 2 revolution, we don't know the time. So what we are going to do, we are going to find the time. So for finding the time, what I have to do, I have to write the second equation. What is your second equation? Theta minus theta naught, which is equal to omega naught t plus half alpha t square. Am I right?
You're right, doctor.
Okay, now we are just going to find the time t1. So I can just make this t as t1. Now I'm going to substitute the value. What is my theta minus theta naught? My theta minus theta naught is 2 revolution. So I have to convert that revolution in terms of radian. So how to convert? We already studied in theory. If you just multiply 2 pi, well, 2 pi with 2 revolution, you will convert it in terms of radian. Am I right? Right or not? One revolution is equal to 2 pi radian, which is equal to what is your initial speed? Because it is start from rest. Am I right? So what is your initial angular velocity? It is 0. So this term will go on plus half. My alpha value is given in the question 1.2 and then t square value. So t1 square we are going to find. So I have to write like this. Now you can see this revolution and this revolution get cancelled. So 2 multiplied by 2 pi gives you 12.56. So 12.56 radian, which is equal to, if you just divide this 1.2 by 2, you will get 0.6 t1 square. Therefore, t1 square, which is equal to 12.56 divided by 0.6. So when you just divide and then when you take the square root, what answer you will get? You will get 4.575 seconds. So if you just take the square, what you will get? Here you will get 20.93 seconds square. When you take the square root on both left hand side and the right hand side, you will get the answer of T1. Understand?
Okay.
Okay. Let's become for the second question. What is given in the second question? What is the time taken for next to 2 revolution? Brother, what does that mean? First, you can listen carefully. The merry-go-round will be rotating for 2 revolution, and next to 2 revolution means what is the total? The total revolution is 4. Am I right? So here my theta minus theta naught is equal to 4 revolution total. This 2 plus this 2 gives you the finals the second time. Am I right or not?
Yes.
Yes, you are right. And
Okay.
we
Now
put again and we find.
again we are going to find, because by using this we are going to find the value of T2. So what I'm going to do, I'm going to use the same equation, theta minus theta naught is equal to omega naught T2 plus a half alpha T2 square. So now this term will gone. Only you have, so here 4 revolution, I have to convert the revolution in terms of radian. So I have to multiply by 2 pi radian for 1 revolution, and here half value multiplied by 1.2 multiplied by T2 square. So now when you just cancel this revolution with the revolution, you will get only 25.12, which is equal to 0.6 T2 square. Now T2 square, which is equal to 25.12 divided by 0.6, you will get the value of 41.866 seconds square. When you take the square root on left hand side and the right hand side, you'll get the value of T2. So what should be the value of T2? Which is nothing but 6.470 second. Once you find this T2, you have to find what should be the change in time, because how long, they are just asking how long time will be required for the first 2 and the next 2. That means you have to take the change in time. Therefore, change in time, which is equal to T2 minus T1. T2 you have here, T1 you have, subtract this with this. What is your answer? Your answer is 1.895 second. Understand?
Yes, doctor.
Yes,
Okay.
teacher.
Brother, this question is one of the important question. I think in many exams we are asking the similar type of questions. So please listen carefully. What is given in the question? In this question, there are 4 sub questions are there. So first of all, we will read the question and then write the given, and then we will work out. So what is given in the first question? In this question, let's read the story. The flywheel with a diameter. That means you just have a flywheel. Flywheel is nothing but it is a rotating wheel. So the rotating wheel radius diameter is given. What is the diameter? The diameter of the rotating wheel is given as 1.2 meter, and it is moving with the angular speed. That means your initial angular speed is given. So what is your initial angular speed? Omega naught. What is your omega naught? 200 revolution per minute. Now, if you just have the diameter, you can easily find the radius. Am I right? So what is your radius? Diameter divided by 2 gives you the radius. Therefore, 1.2 divided by 2, which gives you 0.6 meter. Understand?
Understand.
Okay. Let's
And we
just start with
convert.
the, what, brother?
And we convert the omega velocity.
Yes, you have to convert, because that is your first question. Okay, what is your first question? What they mentioned in the first question? What is the angular speed of the flywheel in radian per second? So in the question, they give the angular speed in terms of revolution per minute. But in the first question, what they are asking, you have to give the angular speed in terms of radian per second. So how you have to do? You have to convert. Therefore, omega naught, which is equal to 200 revolution per minute. So first I'm going to convert the revolution in terms of radian. So what I told you, 1 revolution is equal to 2 pi radian, and then I have to convert the minute. Therefore 1 minute, which is equal to how many seconds?
60.
60 seconds. Now you can see this revolution get cancelled. This minute will cancel with this minute, and finally you will get the answer of your angular speed in terms of radian per second as 20.93 radian per second. That means the first question, you just simply convert the revolution per minute in terms of radian per second. Understand?
Yes, teacher.
Okay.
Yes, doctor.
Let's we go for the second question. What is given in the second question? Read the question very carefully. What is the linear speed of the point on the rim of the wheel? That means they need the value of v. So v is our linear speed. So brother, listen carefully. We already studied the relation connecting linear speed and the angular speed. What is the formula? V is equal to r omega. Am I right?
Yes.
Yes, you're right, doctor.
Okay, now we just take the initial speed as initial angular velocity as a 0, so I can just put 0 here. Now you can see you have all the information. R is given in the question because diameter is given. When you divide the diameter by 2, you get the radius. Our radius is 0.6 meter, and then omega naught we find from the first question. So then you have to substitute the value 20.93 radian per second, and when you just multiply these things, you will get 12.55 meter per second. So our linear velocity unit will be exactly meter per second. That will be the answer for the second question. Understand?
Sure. The second
Yes.
one said, what's the angular speed? Why we find the linear speed?
Read the question. What is given in the question?
What's the angular speed of the
My
flight?
dear, my dear, that is your A question, brother. I'm just solving the second question. What is your
sorry,
second
sorry.
question?
Yes, sorry, sir.
Just read the question. I'm just see. I just write A here. A question is just to convert. B question linear speed.
I think
Understand?
you completed. Oh, sorry, sorry.
Okay. Let's become for third question. What is given in the third question? What constant acceleration will increase the wheel's angular speed to 1000 revolution per minute in 60 seconds? Brother, you have to give the angular acceleration value in terms of revolution per minute square. So no need to convert because they clearly mentioned the question. You have to give the angular acceleration. That means you have to give the angular acceleration value in terms of revolution per minute square. You have to give the answer in terms of revolution per minute square. Now, for finding this angular acceleration, they give the final speed. What is your final speed, brother? The final speed is given. So what is that value? Omega naught is given as 1000 revolution per minute. And then they gave the time. So what is the time? Time is exactly 60 seconds. So 60 seconds, which is equal to 60
1
seconds, which
minute.
is equal to 1 minute. Am I right? Okay, now I'm going to use our first equation. What is our first equation? Omega, which is equal to omega naught plus alpha t. Am I right? So we are going to find our alpha. So I'm going to keep this term here. I'm going to move the term to the left hand side. Therefore, alpha t, which is equal to omega minus omega naught. Therefore, t, which is equal to omega minus omega naught over t. Sorry. This is alpha. This is alpha means this is t. Am I right? Okay. Now substitute the value. What is your omega value? It is given as 1000 revolution per minute minus what is our omega naught? Omega naught is already given in the question. So what should be the value? 200
0.
revolution per minute divided by what is the time? 60 seconds they give. So I have to convert that 60 seconds in terms of minute, which is nothing but 1 minute. When you just work out, you can see here, brother, this minute and this minute, when you just make it, it becomes minute square. So 1000 minus 200, which is equal to 800 revolution
per minute.
Minute square.
Square.
Okay, that's square, yes.
Clear?
Yes.
Okay. What is your last question? How many revolution does the wheel makes during this 1 second? Sorry, 60 seconds. That means within 60 seconds, how many times this wheel is rotating? That means theta value you have to find. Am I right?
Yes.
So I'm going to use, better I can use one more page. Okay. Now I'm going to use the second equation. What is our second equation? Theta minus theta naught, which is equal to omega naught t plus half alpha t square. Am I right? So your initial position, final position, final position, initial position. Initial is 0. So I can just write like this. What is our omega naught? Which is already given in the question as 200. Am I right? So 200 revolution per minute. And what is your time? The time is already given as 60 seconds. So 1 minute plus half alpha value just before we find from the previous question, which is nothing but 800 revolution. So 800
Multiply by
revolution.
1.
So 800 revolution, and then
T square.
t square multiply by t square. That is what's the value? 1 minute
1
square.
minute.
Am I right or not?
Yes, teacher.
Now you can just substitute the value. What you will get? If you just divide this value, it becomes 400. Am I right?
Yes.
Yes.
And this minute get cancelled with this minute. Am I right?
Yes.
And this is unit. What is the unit for 800? Revolution per minute square. Am I right? So this minute square get cancelled. Finally, your theta value is 200 plus 400, 600
600 revolution.
revolution. That's it. Clear?
Yes, teacher.
Okay. So, brother, this question is important question. So please just go through when you just go for your final exam. Understand?
Of course, teacher.
It's easy, because it's like chapter 2.
Everything like chapter 2. All the problems are related with chapter 2. Only thing you have to replace the parameter. Understand?
Understand?
Okay. Read the question. The car starts from rest and moves around the circular track. That means the car is moving in the circular track. That means it is moving in the circular track. So the car is here. For example, you consider the car is here. And the radius of the circular track is given. What is the radius? They just clearly mentioned 32 meter. And its speed increases at the constant rate of 0.6 meter per second. That means its acceleration is given. So 0.6 meter per second square. This acceleration is nothing but it's a tangential acceleration because it is moving in this way. Am I right? So you have two acceleration, brother. Listen carefully. If the car is moving in the circular track, one acceleration will be the tangential acceleration. Another acceleration is the radial acceleration. So this is your radial acceleration. This is your tangential acceleration. So what is your first question? What is the magnitude of the net linear acceleration? So what you have to find? Net linear acceleration. Net linear acceleration. How you have to find? Whether we already know the formula. Finding the magnitude, it is nothing but square root of tangential acceleration square plus radial acceleration square. Am I right? Tangential acceleration square, it's already given in the question.
Doctor, from where we got this formula?
Brother, linear acceleration, net linear acceleration, linear acceleration net value, which is equal to tangential acceleration plus radial acceleration. Understand?
Yes.
Now finding the magnitude. How to find the magnitude? Tangential acceleration square plus radial acceleration square. Am I right or not?
Yes, you are right.
Now you can see in the question they clearly mention about the tangential acceleration, but radial acceleration you have to find because we already know the formula for the radial acceleration. What is the formula for radial acceleration, brother? Radial acceleration, which is nothing but v square over r. Am I right?
Yes, you are right.
But you can see here, is there any information about your final velocity?
No.
No. So they clearly mention the car is start from rest. So your initial speed is 0. What is your final speed at a time t is equal to 15 seconds? Am I right?
Yes, you are right.
Okay, now I'm going to use the first equation, v which is equal to v naught plus at, and we are going to find our initial velocity, final velocity. Your initial velocity is 0. So what you will get, v which is equal to my acceleration, tangential acceleration is given 0.6 multiplied by time is 15. So when you just work out with this formula, you will get the answer of 9 meter per second. Once you find this speed, what you have to do, I'm going to take the value and I'm going to substitute here. If you substitute, what you will get? My radial acceleration, which is equal to 9 square over my r value is 32. So by that I will get the answer of radial acceleration as 2.53 unit is meter per second square. Understand?
Understand.
Once I find this radial acceleration, I am going to find my magnitude value of the net linear acceleration. So I am going to substitute this AR and AT value in this formula. If you substitute, what you'll get? My AT value is 0.6 square. My radial acceleration is 2.53 square. When you just work out, my final magnitude answer is exactly 2.6 meter per second square. So this will be the answer for the first question. Clear?
Clear, doctors.
Okay, what is your second question? Could you please read the question? What angle does this net acceleration vector makes with the car velocity? That means they need the information about the angle. That means we already studied in chapter number 3, theta which is equal to tan inverse of y over x. Am I right?
Yes, you are right.
So what is our y? Our y is the radial acceleration. Our x is the tangential acceleration. So I have to substitute the value tan inverse of AR over AT. So we have the values of this AR in AT. So tan inverse of, so AR value is 2.53. My AT value is 0.6. When you just work out with these things, you'll get the answer of 76.6 degree. Understand?
Understand. Thank you, doctors.
Okay, so one more problem is there. That is our last question. Very, very important question. Please read the question. What is given in the question? Here they just give the information, some word, some sentence wise, and the right hand side of the question have some diagram. Listen carefully. The body is in the figure is pivoted at 0. That means at this point you have some point. What is that? In this point you have the connection at 0. And now you can see two forces acting on it. What are the two forces? F1 and F2 is acting on that. And then they just give the value of R1, R2, theta 1 and theta 2. So now you can see here, they are asking you to find the value of net torque. We have two formula for the torque. What are the two formula? Tau, which is equal to RF sin theta was first formula, and another formula tau is equal to alpha multiplied by I. So you have two formulas for the calculation of the torque. Which formula you are going to use?
First one.
Sin theta.
Because theta is given, R value is given, force is given. So I can just use the first equation. So second equation is not applicable for this question. So what I'm going to do, they just need the net torque. So what is the formula for net torque? Let's just read what is given. R1 value is given, which is nothing but 1.3 meter. R2 value is given 2.15 meter. Force 1 value is given as 4.2 Newton, and force 2 value is given as a 4.9 Newton. And then theta value is given as 75 degree and theta 2 is given as 60 degree. Now, brother, net torque. What is the formula for net torque? Torque 1 plus torque 2. Am I right?
Yes,
Cos
you are
theta.
right.
So what is our torque 1? Our torque 1 is based on this part. Am I right or not?
Yes.
And the torque 2 is based on this part. So I have to apply the rule. How I have to write? R1 F1 sin theta 1 plus R2 F2 sin theta 2. Am I right?
Yes.
Yes, you are right.
Now, brother, listen carefully. We studied in the theory, if the rotational force will be in the counterclockwise direction, the torque value is positive. I told you. Am I right?
Yes, you told me.
If your rotation will be in the clockwise direction, your torque value is negative. I told you in the last class. Now you can see the picture, brother. From the force, the torque value. So here it is rotating in the counterclockwise direction. Here it is rotating in the clockwise direction. So the torque for this part is negative. Am I right?
Yes, you are right.
So I can just put minus here. Understand? So minus into plus becomes minus. So R1 F1 sin theta 1 minus into plus become minus. R2 F2 sin theta 2. Now you have all the values. Substitute in this equation. You will get the net torque as, if you substitute the value, what answer I got? I got minus 3.85 Newton meter. Clear?
Clear, doctors. Just it?
My dear, yes, brother.
Just that?
That's it. This question is nothing. It's a very easiest question. So please Listen carefully. This chapter is one of the important chapter, and please focus on this chapter because you have many formulas in this chapter. So please, brother, study well, work out the problems by yourself, try to get practice, then only you will get good marks in the final exam. Understand?
Understood.
Okay, so that's it. Your chapter is over. Any other question from your side?
Okay, teacher. In the final exam,
Okay.
should we study the here on the
Study that?
midterm?
Yes,
Or
I think less
Yes.
weightage will be given. Less weightage will be given for the first 6 chapters.
like 20%?
My dear, listen carefully. Listen carefully. I just open just a minute, please. You can see you finish 1 to 6 chapter in midterm. Am I right?
Yes.
And then 7 and 8 is for your quiz 2. Am I right?
Yep.
So remaining 9 chapter, 10, 11, 12, 13 chapter is not included. 14 and 15. So from this chapter, the weightage will be more, and from these two, weightage will be less. Clear?
So
teacher,
from 9 to 15, it's more than the half.
Yes.
Okay.
Yes, brother. Any other question?
teacher,
Yes.
the quiz chapter 8 and 7 or 8 and 9?
No. 7 and 8. I clearly mentioned in the announcement. Have you seen the announcement?
Because I thought you said 8 and 9 in the beginning of the lecture.
No. Brother, listen carefully. I say 7 to 9. I thought they will give 3
Okay.
chapters. But finally, when I just talked with the course director, he said only 2 chapters. So 7 and 8.
Okay.
So prepare well for your quiz 2 and please try to get full mark. Understand?
Understood. Doctors, how
Understood.
many
Okay.
questions will come in?
Exactly same like your quiz 1.
10, right?
10 or 11 questions. That's it.
I hope it's easy, doctors.
It will be easy. It will be easy because only 2 chapters. The most important thing you have to work out. You have to just go through all the things and just go and to just refer the problems what we discussed in the class. Based on that problem, we will ask the question for your quiz 2.
Doctors, for the problem, it's come like this problem or different?
No. Same model will be there.
Same model. And
Yes,
same
same
like
model.
like this?
Whatever the problems we discussed in the class, it will be same like that.
Okay.
Clear?
Thank you. Clear.
Okay, brother. I think we can just conclude our session today. I think we already finished this time. Right now, the time is 9:40. Still, you have 10 more minutes. If you have any questions, you can ask me a question. If you don't have any question, you can leave now. No problem.
Thank you.
Thank you, teacher.
Yes, welcome, brother. Yes,
Tomorrow,
brother. Yes, please.
And F2, how we know is it minus or like
Brother,
F1 plus?
Listen. If you just see the diagram, if you just move your F2 if you just move the F2 this direction, then your angle becomes 180 degree. Am I right? So 180 degree means sine 180 degree becomes 0. Am I right or not? So based on the angle, you are just moving the force only in this direction. Right or not? So this is coming in the clockwise direction. So I got negative value of the torque. Likewise, when you come for F1, if you move this side, again your angle becomes 180 degree. So it will be 0. So I have to move the F1 in this direction. That's it, brother. Thank you. And you can see the angle, brother. My dear brother, listen carefully. What is the angle is given? You can see the angle. Theta 1 is 75. So if you want to get the 75, you have to move the F1 this direction. Am I right? And if you want to get the 60 degree, you have to move F2 only this direction. Because if you just move this direction, your angle get increased. But here the angle is a small value. Am I right? That's the reason.
Okay.
Doctor,
Thank you, doctor.
Yes, brother.
I still confused about graffiti in all chapter.
What chapter gravity? What's your
I don't
question?
know when I put the gravity negative. You know, some questions come upward, and we put gravity positive, not negative.
Brother, sometimes in some cases, especially the negative concept and positive concept, you have to consider only for the projectile. Most of the cases, we will consider the magnitude value. Understand? But when
Yes,
you
sir.
come for
Like
chapter number 4,
potential energy.
huh?
Like potential energy.
Of course, because potential energy, you have to consider that. You know why? Because when you change in potential energy, is the negative of work done. Am I right or not?
Yes, you're right.
Why it is negative? Because your gravity will be in the groundward direction. You are doing the work in the upward direction, so your negative value. Am I right or not?
Yes, you're right.
That's
About
the reason.
upward. If
What
it
about
is
that?
upward, the work it will be positive.
How it will be positive? When you just substitute the value negative of work done. In potential energy, you have to compare the potential energy with the gravity.
Yeah, it's always positive, the gravity, right?
Gravity downward direction positive, upward direction negative. That's what you got the answer. Change in potential, which is equal to negative of work done.
Okay, but we have a question. We solve to positive. It said upward.
Upward means upward means, brother, if any object is moving in the upward direction, your G value is negative.
Yeah, yes, it's negative, and you solve it in positive.
When I say positive, brother, just before I said negative of work
Go
done.
to slide, Doctor. I will show you. Slide in potential energy.
Which chapter you're saying?
Chapter, I think, 9, potential energy.
Chapter 9 is the momentum. I think
Oh,
chapter 8.
sorry.
Chapter 8, potential energy. Chapter 8.
Problem to solve.
See here. You have some apple or potato in your hand. You're just moving in the upward direction. That means you are doing some negative work. Am I right? When you just have the negative work, you just apply the formula of the potential energy mgh. Am I right?
Yes, you're right.
What is your G value here? M value is positive and G value is negative because the object is going in the top direction, upward direction. Am I right?
Yes.
So in such a case, you will have this value. Am I right or not?
Yes, you're right. And
Or
work
if
is
you want to use, or if you want to use the formula, the angle value mgh cosine theta. Am I right?
Yes, you're right.
What is your theta? Here 180 degree. So what you will get? 180 value is negative. So mgh.
Minus.
Both are same. Am I right?
Yeah. And when we put minus, it comes positive, right? To gravity.
That means if you put positive means it will be coming downward direction. So both will be downward direction, then theta becomes 0. You get the positive value.
Okay. Doctor, could you please go to the problem to solve? I will show you something. 1 minute. Not this question. Another
This
question.
one?
1 minute. 1 minute. Coming back. One. No, not this. 1 minute. I think some questions come aboard.
That is this one. Still air fall. Still free fall. That means you have to consider your G values negative. That's what we put G value here negative. Do you remember that? This is our question. This is our question. Because the object still in the air, so we put negative. Clear?
Clear. Thank you, doctors.
Welcome, brother. See you inshallah. See you on next class, okay?
Tomorrow we will solve. We will do 2 experiments, right?
I said 2 experiment you have to bring in your hand, okay? When you come for the lab, I think you are going to do your 7th experiment, inshallah.
Inshallah. And 8? You will
8
do?
inshallah, and next week.
Okay. Thank you, doctor.
Okay, brother. See you. Assalamu alaikum.
Alaikum salam.